Welcome to your fourth lesson in Chapter 2, and this particular lesson focuses on additional tools that will enable you to calculate the zeros. Very often this is what they did without, obviously without the calculators that we use today, but I'm going to give you specific things that you can do by evaluating the equation and the function and determine where the zeros might be. So the first one I want to look at is, the first tool I want to look at is called the rational zero theorem. And this tool enables you to look at the polynomial, and I want you to think of the notation for this uses all possible rational zeros are going to be all of the fractions made by what are referred to as P and Q. Let me make that a Q a little bit better. And that takes the last term is considered the P. The first coefficient is considered the Q. And I always remember that it's P over Q because I normally have a number over here. And sometimes the Q is 1. So my possible rational zeros, I really like it when Q is 1 because then I just have factors of the last digit. So I always remember that I really would like that to be 1, and that's going to be my denominator. But let me show you more what it means if we do an example. If I have this function, 3x to the fourth minus 18x cubed plus 2x minus 21, and I want to find all the possible rational zeros, I am going to take that function and I'm going to look at factors of 21 divided by factors of 3. And the numbers aren't usually hard, all right? So if I do that, the factors of 21, you know them to be plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. Also, I listed these in ascending order, but you do not need to do that. You could put the 1 and the 21 and the 3 and the 7. Then I'm going to divide that by factors of 3, which are simply plus or minus 1 and plus or minus 3. Now, I'm always include the plus or minus because I could do two negatives to give me the positive. In this case, I would have a positive and a negative to give me the negative. So if you'll notice over here, I'm not concerned with it being negative 21 or positive 3. Now I just simply list those. So those factors, if I make this fraction and put all of these over 1, well, I'm simply going to have the same numbers. Plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. That's what I said is really nice when you have factors. The first coefficient is a 1. And you know that. You know that the possible real zeros could be factors of the last term. But now I need to also include the 3. So now I need to do plus or minus 1 over 3. So I have 1/3. Plus or minus 3 over 3, well, that's 1. I already have that. Plus or minus 7/3, and plus or minus 21 over 3, well, I already have, that's 7, and I already have the 7. So that is the list of the possible rational zeros. And sometimes I'm just going to ask you, list all the possible rational zeros, and that's what you would do. Now, another tool I want to talk about is something called the upper and lower bound. And I know it's a little weird. If you don't want to cut this out, you can just write that in. And initially I didn't do the example I'm going to do right now, which is why I had it typed up the way I did. But when you want to know the upper and lower bounds, the first thing you're going to do is you're going to graph the equation. The second thing you're going to do is you're going to identify the upper and the lower bound of the function. What's the lowest value it goes, what's the highest value it goes to, okay? Then you're going to test, the third thing you'll do is you'll test that function at those bounds with synthetic division. Synthetic division. So let's talk about specifically the upper bound. When you do the upper bound, if you graphed it, you found a number that you think is the upper bound for the function. You've tested it with synthetic division. And you've done, so let's say you've done synthetic division, then you will get an answer that has all of the signs, meaning all the positive and negative signs for the answer for after you do synthetic division are non-negative. That may be kind of weird to think of something as non-negative, Ms. Reams. Why don't you just say positive? Well, if it's non-negative, that means that it includes 0. That means it's positive or it's including 0. So we say non-negative. Now let's think you have the lower bound. Let's test that. You do synthetic division, you get the answer. Okay, so synthetic division, you get your answer after you've divided with the lower bound. That answer has alternate signs. And what I mean by that is the first value is positive, then the second one's negative, then the next one's positive, then negative, positive, negative. They alternate. Or it could start with a negative and then be positive and negative, positive, negative, positive. They alternate. So you need to remember that the lower bound needs to alternate. The upper bound needs to all be positive or 0. Let me write out an example and we'll try. I'd like to look at this example. This example says the function is 10x to the 5th minus 50x to the 4th minus 3x cubed plus 22x squared minus 41x plus 30. And I'd like you to find the upper and the lower bounds. So you can go ahead and pause it right now if you'd like to, write that down and get that in the calculator. But the first thing, remember, we talked about up here that we need to do for this tool is to graph it. So when I put that in the calculator, I graphed it and I came up, I put this in, y equals, I graphed it, and there's my function. Now remember a way, you didn't watch it draw that graph, so remember the way to get it to redraw is right here where it says draw. We're going to do that again. So I'm going to do second draw and I'm going to hit enter. Watch it. Here it comes. There it goes. So by looking at the graph, an upper bound would probably be, let's see, 1, 2, 3, 4. That looks like it's to the left of the 5, but it's so close. I'm going to go ahead and try to say 6. And over here, the lower bound, I think I'm going to try -2 because it looks like it crosses there at -1. All right, so I am going to try the bounds -2 and 6. So I did this. I identified what I thought was the upper and lower bounds. Now I need to test both of them with synthetic division, which is a bit of a trick because look at all of these numbers. So let's first try the -2. Here I need to get my coefficients. 10, make sure I'm not missing any. 4, 3, 2, 1. All right, 10, -50, -3, 22, -41, 30. Okay. Drop the first number. Multiply, that's -20. Add, that's -70. Multiply, -2 times -70 is 140. Add, 137. Multiply, 137 times -2 is a -274. add, that's going to be a negative 252. Now I'm going to multiply negative 2 times negative 252. That's 504. Add, I'm going to subtract 41, and that's going to be 463. Multiply, my fingers almost don't stretch. Negative 2 times 463 is a negative 926, and I add that to a positive 30. I'm going to get a negative 956. Oh, that's not right. I would, let me see if I did my multiplication right. That's 2. That's right. So I did my math wrong. And let me check. All right, my math was wrong on my key. Well, that's unfortunate, but it's still 8. Let's see, that would be 896. Okay. So let's check our signs. I go from positive to negative to positive to negative to positive to negative. Yay! Okay. So my signs alternate. So negative 2 is a lower bound. Okay, let's test the 6. So 6, I have the same coefficients. I know I just blew through this. I caught one mistake. Let's see if I made any more. All right, so drop the 10, multiply, 60, add, positive 10, multiply, 60, add, positive 57, multiply, 6 times 57 is 342, add, 364, multiply, 6 times 364 is 2184. Subtract 41, and that's going to be 2143. Multiply by 6, that's 12,858. Add 30, 12,888. Look at there. They are all positive. Signs all non-negative. So 6 is the upper bound. All right, so far we have learned 2 of the tools. We've done the rational zero theorem, and we've done the upper and lower bound. The third tool is called Descartes' rule of signs, and that particular one looks at the positive and the negative options that you have for the number of roots. It's very nice to be able to say, oh, you're only going to have this many positive roots or this many negative roots, and it cuts down on the ones you need to try. When I was in college, when I did this problem, and I had to, and I got all these possible rational zeros, I had to do synthetic division with all of those to prove which one worked. I could not put it in my graphing calculator and just find the one that worked. You are able to put that in the calculator and say, oh, I know which ones are going to work, Ms. Reeves. But we had to prove it. We had to get the list, and then we had to do synthetic division with each of the positive and the negative ones. All right, so understanding and knowing how many positive zeros you have or how many negative zeros you have can really reduce your workload if you know you're only going to have the positive, or you only have one positive or no negatives, etc. So for the number of positive zeros, in order to calculate that, you count the number of sign changes, and by that I mean positive to negative, negative to positive, in the function itself. Just how many times it changed. Okay? Then you're going to, that is the number of positive zeros. Is that number, but you also need to subtract 2. And you're going to subtract the number 2 as many times as you need to get to 0 or 1. You start to get to a negative value, you'll stop. And the reason we subtract an even integer is because, remember, if you have a function that has an even multiplicity, then it's going to just touch, and so you're going to subtract an even number in case you could have the large number of the sign changes, but you could also have 2 less. And it would go in groups of 2, which is why you subtract the even number. All right, the number of negative zeros would be you're going to count the sign changes in the function at negative x. Okay, and then that number of negative zeros is that number, or subtract 2. When you come back in the next video, we will do an example of this, that example 3 that's on your note sheet, and we will work through that with all of these different tools that you've learned. See you then.